Hi, and welcome to our next video for this unit on precipitation. We're going to be talking about the reason that precipitation occurs and three main different types of it. The process is, well, we're going to give you the simplified version of the process. You may study it a little more in physics, perhaps, and then you'll go into kind of more detail. Maybe it'll be in chemistry, I don't know. You'll go into more detail about the molecular kind of actions that happen. But for our purposes, all we need to know is that warm, and so less dense air, remember warm air kind of, its molecules move very fast and are far apart from each other, can hold more moisture, which when it's in gas form we call water vapor, than dense cool air. It may help you to imagine that the cool air is so dense and tightly packed, the molecules in it, that it crowds out the water molecules, the water vapor, and that's okay. That's kind of only metaphorically how it happens. But if that helps you remember it, then that's okay. You've surely boiled something on the stove, and the really hot air that comes off of it, you can feel the steam, the water within that really hot air, which is something that cool air doesn't generally have the property of. When warm, moist air turns cool, it does that possessing a certain amount of water vapor that it already had. And so when it turns cool, it can't keep all that water vapor anymore in gas form, because cool air can't hold as much water vapor as warm air, and so the vapor condenses into a liquid. It turns, it's still H2O, but it turns from H2O in a gassy state to H2O in a liquid state. Now you've seen this happen, for instance, when glasses sweat. When we say they sweat, it's kind of a, we're not exactly using the right word there, because the water doesn't come from inside the glass. So if you have a glass of Coke with ice in it, it's not like Coke sweats through the glass. What forms on the outside are little droplets of water, and those droplets had been in the air around the glass. When you have that glass, that icy cold Coke on a really hot day, usually the hot day there's going to be more moisture in that warm air. So as the warm air flows past your Coca-Cola, it touches the cold glass. The cool from the glass helps chill down the warm air. The warm air can no longer hold certain amounts of moisture within it, and so the little bits of water vapor that condense on the side of the glass. So it's almost like the hot air has come by and dropped off a little bit of water vapor, and then headed on. Not quite as hot as it used to be, but still hotter than the water inside the glass. Anyway, when this happens out in the atmosphere, the water droplets, there's no glass for them to stick to the side of, so they kind of clump. They kind of tend to clump together, the little droplets, and they look like clouds. Here, as you can see, this hot air is starting down on the surface. It's at 92 degrees, but as it moves up into the atmosphere, it loses its heat. So finally, by the time it's at 6,000 feet, its temperature is only 60 degrees Fahrenheit, which is cool enough for the water vapor in there to condense, turn into a cloud with tiny little droplets floating in it. But at a certain point, the droplets are going to grow too large to kind of be held up by the resistance of the air, the air does put off a certain amount of resistance to letting the droplets fall. That's one reason you can have things like fog or mist, which are also just kind of slightly condensed water in the air, but not at a degree that all the water starts falling as precipitation. That happens, the precipitation occurs when the droplets get really big. They can't stay suspended in the air anymore, and so they fall. If it's a normal temperature, it'll be rain. If it's cooler, it might be snow, sleet, or hail. Now we're going to talk about three main causes of precipitation, or you could say types of precipitation. The first type is convectional precipitation. We've already talked about convection. You remember convection is the process by which hot things expand, become less dense, and rise up, and then gradually become cooler. When this happens with the air in the atmosphere, it starts out as hot surface air. Because it's hot, it expands, it rises, it gets finally to an area, high enough above the Earth that it's cooled down a bit. It can't hold that water vapor, as we talked about, and so it rains. This is kind of the simplest type of precipitation. Another type is called orographic precipitation. A tricky word. Make sure you remember it. It's not Oreo like the cookie. Orographic precipitation. This is due to mountains. When this happens, warm, moist air is forced to rise because, say, it's the hot air is blowing in from the water, and it hits this mountain. What can it do? It's not just going to stop. It's going to keep on going, but it has to move up. And again, as it goes up, it's going to lose temperature. It's not going to be able to hold as much water, metaphorically speaking again, and the water vapor is going to condense and fall as rain. Now, what this does a lot of the time, and you can see this in places like Portland and Seattle, which are on the ocean side of the windward side of the mountains, and that means they have very, very wet climates. It rains a lot there. But once the air keeps on going, maybe over the mountains, but now it's dry. So it means once air gets into this area over here, there's nothing for it to there's nothing for it to drop in terms of rain, because it dropped it all over on this side of the mountain. Which means that on the far side of a mountain like this, you're going to have a very dry area, and that's what you have in eastern Washington, in eastern Washington State, in Idaho and Montana and eastern Oregon, because all the moisture has kind of been pulled out of the air by this forced climb up the mountain and the orographic precipitation that followed. And finally, you have frontal precipitation. This occurs when a large mass, a front of cool air, meets one of warm air. And you guys remember that cool air is denser, so it acts heavily. It acts more heavily, or it acts more heavy than warm air. So, as the cool air comes in here, it's going to hit this front of warm air. But because cool air is heavier, warm air is lighter, that means that the warm air is forced to go above the cool air. The cool air just kind of acts like a wedge, just like lifting up the warm air. The warm air, once again, due to the kind of principles behind precipitation, as it rises, it loses heat, it can't hold its moisture anymore. That moisture falls maybe in the form of rain, or some other kind of precipitation. Whew. And those are your 3 types of precipitation. Good job, and I'll see you in class.